Good evening, everyone. Today's session is on basics of data structures. So, we will be learning in this session what is ADT, abstract data types, what are linked lists, what are the application of linked list, where these data structures are implemented, what are the applications of these data structures, right? And first of all, before starting that, we need to understand why we require data structure, right? So we need a algorithm for that, right? So let us begin with the session. First of all, whenever we have to maintain any data structure, anything like any sequence, we need to have a pseudocode or an algorithm to be implemented. Now, this algorithm has its own advantages. Like you need to have, you are going to provide the optimal solution for the problem, right? The second thing is in terms of time, it should take less time and less memory also, so that it is going to benefit for the programmer also. So let us begin with the session. The first is a pseudocode. What is a pseudocode? Pseudocode is just a rough code, or you may say it's a sequence of statements. It rough code, it doesn't mean that it does not have logic. It has the logic, but the only thing is you have not written in any programming language. So it's just a raw sequence of steps, right? Like if I'm going to prepare addition of a program that is going to have addition of two numbers, so what will be the sequence while executing while getting the result? So like in pseudocode you are just writing the steps, need not have to be implemented in any programming language, that is either C or C++ or Python. So it is not required. Pseudocode is a code which tells the logic behind the algorithm, right? So let us see what are the main things that needs to be included in pseudocode. Pseudocode is an English-like representation of the algorithmic logic. So I told you, logic is implemented behind this pseudocode. It consists of an extended version of basic algorithm constructs, that is sequence, selection, and iteration. It could be a sequence of statements. It could be control statements, like you may have if and else part under this. You may have conditional statements under this. You may have even looping part under this. Some iteration that needs to be executed again and again. Suppose I want to print 10 numbers. I want to print a table of 10. Right. So again and again, I'm not going to type it like 2 ones are 2, 2 twos are 3, 2 twos are 4, 2 twos are 2 threes are 6, and this, so on. I'm not going to write each and every statement. What I'm going to do is I'm going to use an iteration, use and looping concepts. Right. So a loop is going to automatically suppose I'm giving an example of ATM. Now earlier we used to have so many things, like you need to when you need to deposit a cash in the bank, you need to stand in a queue, then deposit the money at the deposit counter. Now automated process, it is basically this process is replaced by ATMs. Need not to deposit or need not to uh, withdraw the cash in a queue, standing in a queue, and maintaining the timings also. Like at night also I can go to ATM and I can withdraw or deposit the cash, right? So now it has become automated. So like that only, like when we have iterations in implementation, iteration is what a looping concepts which basically iterate the process, repeat the process, need not have to be written one by one. That's what I'm saying. Like if you are going to type a table of 2 or a table of 3, 10 times you need to print the same table, right? But with the some other logic, like it should increment the I value also. It should basically calculate the results as well. We are not printing 2 into 2 10 times. We are printing the table. The logic is like I is also incremented and the product is also changed every time, right? So some logic is there behind that particular loop. So what is that? We need to write an algorithm. And if we are not using any programming language, it would be treated as a pseudocode. So pseudocode is a code which tells the sequence of the statements that needs to be taken. It could be a looping concept that is to be implemented. It could be a selection statement. It could be only the sequence of statements, right? What it should include? First of all, it should include the algorithm header. What this algorithm is going to do, what is the purpose, what is the condition, and what is the particular function, what it is returning. Like suppose I am saying I'm going to have a, um I'm going to check whether the number is prime or not. So I may be taking some value as an input, then checking the condition, checking the logic behind that, that if the number is divisible by itself or 1, and the how we are going to implement it. So we will be using some operators, we will be using some variables, right? So this is how these things are included, like statement numbers, variables, statement constructs, or algorithm analysis. In algorithm analysis, you need to understand like what will be the running time for the algorithm. Like if it is taking too much time, obviously it would be costly for the developer itself. The developer is going, that means the logic behind that is not following a standard, or it is not going to provide the optimal solution. So we maintain the time factor as well as the cost also. If we have a thousand lines of code and the same logic is implemented within 10 lines of code, so it would be like there is a great difference between both of them, thousands line of code and 10 line of codes. So the logic can be implemented using 10 lines of code, using iterations or using for loops or looping concept, rather than we are repeating the each and everything. So at the time of analysis, we basically check out whether the algorithm is providing the optimal solution or not, right? Let us start some of the data structures that we have and what are the advantages of them. So first of all, they all come under this abstract data type. Now, what is abstract data type? Abstract data type basically consists of data declaration packaged together with the operation that needs to be performed on the variables, on the data, while embodying the structured principle of encapsulation and data hiding. So, whenever we talk in terms of object oriented programming language, or there are basic concepts of object oriented programming language or ADT, we say that we encapsulate wrapping of data and hiding, that is abstraction, data abstraction. So, what are these two? Let us understand how it is implemented. Suppose I'm taking my Gmail account, right? And my Gmail ID. There are two things behind that. I need to sign up in the Gmail account. My Gmail ID is public, like anyone can send me a mail. But can my password be a public? No. So, how to make it private? So, this is the bifurcation. We encapsulate the data that is not seen, that is hidden by the users, right, by the other people. So there is some restriction behind that. We wrap up the data in such a way that the part that is publicly shown to the user is treated as a public variable, and the data which is shown as a private data, like your passwords, you cannot share your bank account password to anyone, right? You cannot even share your user IDs also in terms of internet banking. Whereas in your Gmail account or your Yahoo Mail account, you may share your email IDs, right? So this is what we need in the while implementing the using this abstract data types, right? Now, what are the advantages of abstract data type? It basically, like you have a big program, you have a program that contains all the functions. It's a complete program. Now, how you are going to test it? How you are going to maintain it? Right. So what is the logic behind that is modularity is the concept in which we decompose the problem into number of small functions so that each function can be standalone, tested and debugged, and the main important thing is can be reused, like your login function, login module. The login module can be reused at any end, like the same login module is used by all the accounts, all the email accounts you have in Yahoo Mail ID. In Yahoo Mail ID you have the sign up option. In any application where you need to sign up, you can use that module, right? Need not have to test it again or debug it again. You may reuse it directly. So this is what these are some examples of why we have modularity, why we have small functions, and why we what is the main advantage of reusability. So the reusability, you need not have to test that particular module again and again. Right. Once you have written, once it is tested, the only thing what you need to do is again you may just integrate it with your other applications, other modules, right? And even it is easy to change also. Why? Because if there is like in a single module, if you want to change anything, you can just move to jump to that particular module and you may change it. If it is a big code, then you need to maintain the sequence also, and that you need to check the cohesion part also, like whether the elements of that module is dependent on other modules or not, or within that module also, right? So when we are using ADT, we have certain advantages, and we need to use those advantages, we need to use those features, characteristics of ADTs in our program. Now let us start with the three data types. What are the data types we have in any programming language? The first data type is integer. It may consist of numbers, the floating point numbers, a decimal point number that is, and a character. Character means you have uppercase character and you have lowercase character. And let us see what are the operations that we can perform on any data type. Like in operation in integer, we can perform all the arithmetic operations plus your increment and decrement and so on. There are a number of operations that can be performed on an integer. Whereas when we have floating point data type, you can perform all the same thing as integer. You can perform all the arithmetic operations. Now we have characters, like I want to compare between two characters or two strings. Like this name AB, and like I am going to compare the student name is equal to other student name. So we can compare with the help of comparison operators. So these are the basic data types that we have, and we are going to use it. Then we have how to have a array. Array is basically, array is a data structure which is holding the value that are homogeneous in nature. Right. Now what is a before starting with this, I am going to tell you the three important points related to data structure. Aggregation of atomic and composite data into a set with defined relationship. Structure refer to a set of rules that hold the data together. So you have some class, you have some array, you have some linked list, you have some list, you have some structure, you have some union. So there are different data structures according to your application. You may select any of them, right? And each of the data structure has its own advantages. They are, yes, they are related to each other because the set of associations between those elements they have the relationship between them, right? Or sometimes, like if I'm going to ask you to maintain a record of a student, so how you are going to maintain a record? List is containing the name of the student, the age of the student, the mobile number of the student, the address of the student, right? It is not including that uh, all the values that I'm talking about, all the attributes have the same data type. It cannot be possible. The name is in numbers. So, when we are maintaining a record, it consists of heterogeneous combination of data into a single data structure with an identified key. So, what we want to say, that means a structure which contains any type of data, right? It is not dependent, like all the values are homogeneous in nature. It is said like all the values could be heterogeneous in nature. Then we have, in comparison, there may be some association between those elements, there may be no association between those elements, right? On the other side, when we talk about array is a collection of same data types. Like we can perform arithmetic operations too on that particular data structure, that is array. So what is array? Like I am maintaining the height of 10 students, or you may say I'm going to maintain a weight of 10 students, age of 10 students. So obviously I'm making a list, I'm making a data structure that is containing the record of 10 students, right? That is, all are of same data type. That means homogeneous sequence of data or data types are known as elements of that particular list, that is array. Position association among the elements. So you can basically, and the most important point also, you can have arithmetic operations that can be performed on that array, right? So these are some examples of data structures. Then we have, this is again a example of some other data structures, like you have graph, you have tree, you have matrix, in which is a which would be like containing the rows and columns, linear list, all lists are connected to each other, or the elements are connected to each other. So these are some other examples of data structure. Now let us understand the basic attributes, the basic knowledge behind the abstract data type. ADT users are not concerned with how the task is to be done, rather what it can do. So it talks about what is the problem, how you are going to solve it. That is not done by this. An abstract data type is a data declaration packaged together with operations that are meaningful for that data type. So suppose I am going to maintain a record. So I may not be using some arithmetic operations. If I'm maintaining a array, I may be using some arithmetic operations on the elements of that array. We can encapsulate the data and the operations on the data and then hide them from the user. Now, why there is a requirement to hide them from the user? That's what I have given the example of your login details. You may share your login ID, but you cannot share your passwords. So that's why it should be hidden from the users. All references to and manipulations of the data in a data structure are handled through defined interfaces to the structure. So you have the basic thing. What is that? Access specifiers in that, where you can do that thing, which part is manipulated, which part can be manipulated, and which variables or which data or data members cannot be manipulated, right? Now, this is the basic data type model of ADT. ADT contains your public functions and your private functions. Under your public and private functions, what are those functions? It could have some data structure that I told you, that could be an array, that could be a list, that could be a linked list, that could be a record, That could be a tree, that could be a graph, that could be any way. And that is connected to an interface with the application program. How the user is going to access this. Right? So this is the basic architecture of data type model. Then we have how to implement this ADT, how to implement this abstract data type. For implementing this, the basic data structures that we use to implement ADT are array implementation and linked list implementation. So first of all, we will be checking out the linked list, right? No, in the previous lecture, we have already studied about how linked list, what is linked list, how linked list is maintaining the elements in the memory. Right. So suppose I am taking the example of linear list. It is a list which is starting, you have the data and link is the address of the next element in the list. Right. So you have a list. First part you have a list and then you start with that the data elements have two things in your linear list. The first is data value, whatever the value in that element, like suppose 40, and the link is the address of the next element in the list. Whereas when we have non, and they are continuously there, like they have a linear sequence, or you may say linear continuous data is there, right? Whereas when we have non-linear list, we can have what? We can have two things: the address of the previous element, and it is divided into three parts. The list, the element of any list is divided into three parts. What are those three parts? The first part is denoting to the address of the previous element, and the last part of the link is, there are two links in a data, right? You can see on my screen. The data is holding the data value. The first link part is holding the address of the previous element, and the next element and the last part of this is holding the address of the next element in the list. So this is how it is maintaining the list, right? So it is called non-linear list, and there is empty list, there is no element in the list. Then we have how we have nodes in our list. So we have first node in a linear list. We have seen there are two things. The first is data and the link part. The link is basically representing the pointer to the next element in the list. And node in the non-linear list will contain the data and the link and the address of the previous element, like in this, the address of the previous element in the list and the address of the next element in the list. So this is how it is maintaining the part. Let us see some more examples, some node structures I have taken, which is representing the record. So node with one data field, you have any number and you have the thing is the address of the next element. Node with three data fields. So you have three data fields: name, ID, grade points, and then the address. This thing, they all are having a linear list which has only the single link, and single link means address to the next element in the list. Then structure in a node. How to maintain a structure in a node? We can have any data type like name, address, phone number, and the link part contains the address that is pointing to the next element in the structure. Now let us see the algorithm efficiency, which basically contains to design and implement algorithms. Programmer must have a basic understanding of what constitutes good and efficient algorithms, right? So you have number of looping concepts in this. What are linear loops? You have linear loops. Loop update either adds or subtract operations only. Efficiency is a function of the number of instruction. Now I told you, like if you are writing a addition of number in 10 lines and I am going to write that in 2 lines or 3 lines. So obviously my logic is doing well, and sometimes you have the lines of codes are more than the simple logic can be implemented, but it has its own advantage. But besides that, we should use those things which are efficient and less number of lines of code. Then we have logarithmic loops. What are logarithmic loops? It is basically controlling the variable is either multiplied or divided in each iteration. So you have some logarithmic loops. The number of iteration is a function of multiplier or divisor. So they have their own importance. In the coming lectures, we will be dealing with some examples which is using linear loops or logarithmic loops. Let us see more loops behind that are nested loops. Now, what are nested loops? The number of iterations is the total number which is the product of the number of iteration in the inner loop and number of iteration in the outer loop. So you have nested loops also. Like you have for loop, basically it is used in sorting algorithms. You have quick sort, you have merge sort, you have number of sorting algorithms, insert sort, you may have merge sort, you may have number of algorithms through which you can implement this nested loops, right? Where we require these nested loops. Then we have bigger notation. What is bigger notation? Not concerned with exact measurement of efficiency, but with the magnitude. Now, magnitude means when basically time factor is considered. Like if I am going to use a bigger notation or omega notation, or you may have, there are number of types of notations in this. So we are checking what is the complexity of that algorithm. How efficient is this? So with the help of asymptotic notations which are used in algorithms, we are going to find the efficiency of that particular algorithm. Then we have the main thing, what are the advantages of linked list that we have just seen. Need to know where the first node is. The rest of the nodes can be accessed. So you need not have to see like all the addresses. The first node is carrying the address, the link part that is holding the address of next in the instruction, next element in the list. So if you know the address of first node, you can find out other nodes. No need to move the elements in the list for insertion and performing deletion operations. No wastage of memory. The main and biggest advantage behind linked list is no memory wastage. Then we have arrays. Arrays pros and cons that we have understood. It contains only the homogeneous collection of data, right? What are the pros behind that? What are the advantages behind that? Directly supported by C language. You may use C language, you may use C++ also. Provides random access. You can access any of the element by using the index of that. Cons, the size determined at compile time. So in this case, there may be wastage of memory, and in most of the cases we find that there is wastage of memory rather than utilization of memory. So inserting and deletion of elements in is very much time consuming. Then we have what are the pros and cons of linked list. The advantages behind linked list is size is determined during the runtime, execution time actually, and you can perform easily the deletion and insertion of elements in the list. No random access, users must provide programming support. So you need to have to perform some complex tasks. You need to have a knowledge of how to use different syntax while implementing linked list. Now these are some applications on list. List can be used where to store the record sequentially, for creation of stacks and queues, for polynomial handling, and to maintain the sequence of operations for do or undo in the software. To keep the track history of websites, the most widely used thing. You have an history on Google Chrome. How it is maintained? It is one of the application of the list of that is data structure, right? So hope you have understood the basic concepts of data structures and understand why we are using linked list or why we are using arrays, right? So we will be having more sessions on linked list and arrays. Hope you like this session. Thank you.